The recorder is on. We have been working, trying to get this video of 7.9 up and running. I'm going to get over there and figure out what the problem is. I can see it just fine. Obviously, I'm looking at it right now, but not everyone else can see it. Okay, the time is 6:05, a couple minutes late. The date is July 16th, 2019, and this is the scheduled meeting of ITSC 2309. And what was I doing here? I had something on the up to do. Modules today. Okay, I was going to come here. Let's see. We're working in module what?
8.
Module 8, which is the subqueries. And let's see, that's here. So I'm going to step into, you see on mine, you see a module 9, but I've got that grayed out. I'm not doing it right now. We're going to step ahead to module 10, so there'll be a little break in it there. And so we'll be in data types today. The subqueries are here, and we've been discussing subqueries. Let's review. A subquery is the simplest case. The subquery is in the where clause. Select vendor ID, vendor total from invoices, where invoice total is N. So N is typically used instead of equal to. Could have used equal here, but I prefer in or not in, and I prefer greater than all or less than all, as opposed to just greater than or less than. And then a subquery, and this is a very, very common use for a subquery of finding the maximum, finding the vendor ID with the maximum invoice total. So select vendor ID, invoice total. So if I have 5 of them that are tied for the maximum invoice total, I'm going to get all 5 of them. And this is very common. Now here in this particular one, I can get away without an alias. If you want to alias it, that's your business. It really doesn't matter where it's in there. You don't have to put an alias on this one. Normally, when we have a derived field like this or an aggregated field, we would give it a name as X or whatever. But we don't have to here. It's okay if you don't. Let's see, again, we're seeing duplicates because if I have 2 invoice totals for this vendor where the invoice totals are the same, so if this vendor has 10 invoices and they all total $10, I'm going to get them repeated because they all satisfy this. So if the vendor is the maximum, I'm going to get duplicates. Well, we can put the distinct in there. Select the distinct vendor ID invoice total, and that will suppress it, and that's fine. Most of the time, I don't really care if I have duplicates. Most of the time, I'm sending it up to a web page for further processing, and I'll worry about that when I get up there. Okay, here's a change. This particular subquery, this is the other kind of a subquery that can be in the from clause. Now, this one is a very powerful idea. Let's see, we've already done the correlated subqueries. This is called the derived subquery, and it's not really difficult. It's just that the subquery is in the from clause. What is a subquery? What is a query? A query is simply a table. So the query always returns a table. This particular one says select from a table. Well, what is this? This is a table. Therefore, I can select from it. So select from this table, and this table says select vendor ID, max invoice total, bug number 1. On this one, you must alias the aggregate fields and derived queries. This one up here, I can get away without it because it's in the where clause. When it's in the from clause, it has to have a name. Must alias all of these guys. So anything that will show up as unnamed column has to be named. From invoices grouped by vendor ID, the reason I have the group by here, well, the old new rule there, I have an aggregate field. I have a field that is not aggregated. Therefore, I must group by the field that is not aggregated. That's going to be true in any database product. That will always be true. Just learn that rule. Bug number 2, I must alias, I must give a name to this derived table. I typically use D. Why D? I don't know, because it's derived. X is fine. It really doesn't matter. Notice I'm not using that name anyplace. I might, but I just have to give it a name. If you want to name it X, that's cool, but you must alias. If you don't give it a name, you will get, for your reading pleasure, an error message up here and down here. And then you'll be sitting there going, well, why? You know, does it need a semicolon? So you put a semicolon and all kinds of stuff. And I've chased that bug so many times and I'm sitting there, why? And then I forget, oh, duh, I've got to name the tables. So the tables always have to have names. I cannot select from an anonymous table. This one is an anonymous table. Now, I wonder what would happen if I gave him a name as X. He's going to throw me an error. Okay. It wouldn't surprise me if there were products that allowed you to name this table, but there's no reason to. This one has to be named in all database products. If there are questions, that's fine. If there aren't, I'll move on. Joey, you doing okay? Okay.
Yeah, I'm good.
Okay, we cool. Hey, let's go back. Let's revisit this problem we had early on. And we wanted to do something like this. So like, remember the old balance due? And invoice total minus payment total plus credit total. We're going to be seeing that guy for a while because it makes a real nice derived field. You could have said invoice total minus payment total minus credit total, or there's other ways you could have done it. But that's the simplest. And we give it the name balance due. And I pointed out here, and this is important to understanding SQL. SQL isn't evaluated from the top to the bottom. The first thing that gets evaluated is the from clause. The second thing that gets evaluated is the where clause. After that, the third thing is the select, and then the group bys come in there. I think the group bys come in with the where. So I think they're second and third. Then the select clause, way down in the list, the select gets evaluated. And finally, the last thing that happens is the order by. If you think about it, it's got to figure out what table to go search before it does anything. So figure out what tables you need, then figure out what rows you need, then figure out what fields you need, and then order them at the very end. Therefore, this select falls at the end. So this would error out because balance due, evaluated second, does not exist when the where clause is evaluated, because it doesn't happen until the select line gets evaluated. And okay, it's kind of a pain in the neck, and I've always thought that, well, they should do something about that, but they're not going to do it just because I think so. That throws an error, yabba yabba. Here is a workaround to it. Now, I don't know whether this is of any great use to you or not, but I can use the where the balance due. I can use balance due in the where line if I create it in a derived query. For example, this particular one creates and select invoice ID, invoice total as balance due. So he comes into existence as far as the outer query goes on the from line. So at this point, now balance due exists. And the select line says select invoice ID balance due from this table. Now I can use balance due on the where line. Now, I don't know how great that is. I don't know that I would go through the trouble of creating a derived query just so I could use balance due on the where line. It doesn't bother me a whole lot just to use my copy and paste here, copy this and paste it down on the where line. Seems like that would probably be the simpler way to handle it. But this way we'll get it where I can use, if I need to use balance due later in the query and he isn't getting created in time, I can cause him to get created in a derived query like this. A derived table, excuse me, I should have said derived table, not derived query. Derived table has all of the properties of any other table in the query. It may participate in a table join, inner join, outer join. It may have subqueries of its own, and you can get really complicated. For example, I'm going to add the vendor name to this query up here. Now, anytime I'm taking stuff from two different tables. So I'm taking stuff from the invoices table and I'm taking stuff from the vendors table, link table. I'm stuck with a table join. There's really no good way to select the invoice, the vendor name and the invoice associated invoices. The only way to do that is a table join. If you want unmatched ones, then you want an outer join. Most of the time it'll be an inner join because most of the time you want them matched. But this time, I say, in this case, I want to use balance due down in the where clause for some strange reason. Maybe I'm just trying to prove a point that it can be done. Or maybe there's a reason why you need to do it that way. For your web page has to have it in the where clause for some reason. I don't know why that would be. I can select vendor name. Vendor name is going to be in the select line. That means that I have to have the vendors in the join. So from vendors, and I usually will alias mine. Inner join what? Inner join that derived table up here, D. On v.vendor ID equals d.vendor ID. Where balance due is greater than 0, order by balance due. Sometimes I'll put the order by on the where line. I'm not saying that you always should, but usually when they're fairly simple, I will. Again, there's a lot of leeway in that. Let's see, what was I going to say here? Oh, so sometimes you use a derived query to hide information. So it would be possible that the invoice ID is, let's say it's confidential. Let's say that we're not allowed to divulge that. So we have to hide it. I can hide it if I don't select it here. It is not available in the query anyplace because if it's not selected, but I would have to select the invoice ID if I were going to do the table join on the vendor ID. So it's handy for hiding stuff. I think I didn't say something exactly right there. I would not have to select it, but if I took it out of the query, it would work just as well. I would have to have it here because it's needed for the join. Questions? And that just about wraps up chapter module 8. See, I believe I've made the assignment on module 8. Okay, well, I got 2 people here today. Well, I'm going to move on.
Well, I'm going to ask you a quick question.
Go ahead.
But so, is the intermittent table formed at the select, which is what I think it happens or think happens? Because as you were talking about the order of precedence or the order of processing, rather, the group by doesn't have to be visible in the result set. So you can group by a column that you don't have to select, which means it must process the group by before it processes the select, right?
Let me think about that. I believe that the group by is processed before the select. Yes. Yes, that's true. The group by is probably, I believe the group by comes right with the where.
Well, actually, I have, let me see. Well, the where before the group by. The where's before that.
Let me get back.
I don't know if you could do it
if that's important, which order where the group by comes, I can look it up and get back to you.
That's okay. I can play with it and test it, but I was just really kind of getting at the idea that, so when you select, that's your intermittent table. Is that correct? And so whatever you don't have in after you select, that then affects your having and your order by.
Let's see. Select. No, you can order by something that is not in the select, and your having does not have to be in the select.
Okay. Well, I'm going to have to go back and reread that. I'm sorry. Thank you. Never mind.
Yeah. Did I say something that where it sounded like it did? I don't believe the select comes very late in the processing.
Okay.
So it creates all the stuff and sends it up. The idea would be I like keeping classified material out of that. Anyway, I believe that the group by, so it does not have to be in the select to group on it. It does not have to be in the select to order on it. And I don't think it has to be in the select to be in the having clause. Others? Okay. I believe I've made the assignment on this on module 8, and I'll take any questions on it. Moving on to data types. Well, actually, when we finish chapter 8, we have essentially finished the SQL syntax. Anything you can do in SQL, you can do with what we have covered. There are some other little nuances that we'll talk about as we go through it. But for right now, as we go into data types, we're going to be talking more about programming, and we're going to have some programming matters will come up. Data types. Let's see. I try to find another decent video to put in there. I'm not sure I was real impressed with this one. I might try to look through this. Define and explain the 4 fundamental data types used in SQL and generally in programming. Casting and converting, changing data types, and calculating disk space requirements and how these data types, how much disk space they require. Okay, here's the bottom line is data types are fundamentally four things. There's strings or character data. It's either string or character, numeric, numbers, times, dates, or both. And this one isn't very exciting, but I thought I'd mention it. We call them blobs. Binary large objects, there's other names for them, clobs, and I'm not sure what that means, but basically a binary large object would be like a digitized fingerprint or a voice recording, or it could be a movie digitized and put in there. They're not real exciting to us, to a database person, because they're just kind of there. They take up space in the database, but they're kind of stored someplace else. We really can't search on them. I mean, I can't search for a movie about whales unless I have that metadata someplace else. So if all I've got is the movie, I don't have any idea what it's about from the computer standpoint. So everything the things that we're interested in are the first three, because they're the ones that are more interesting. The digitized fingerprints and the pictures, your picture I could put in the database, doesn't really do any. Oh, come on. Doesn't do much for us. Next. Okay, integers. I'm going to start off with this one. Integers are our favorite ones. We like integers. Computer scientists love integers. Computer programming always treats integers the same way. Two decisions. Does the integer have to represent both positive numbers and negative numbers? This is an important one. Or is it just a number, starts at 0 and goes up to some arbitrarily large value? If it is, and then how much storage will we allocate for each integer? For an integer, 4 bytes is the most common. We find 4-byte integers in almost all programming languages and all applications. It's not the only one by a long stretch, but that's real common. Okay, if it is signed or unsigned. If it is unsigned, that is the simplest one. We convert it to base 2, and that's all. We just do a conversion. We go from base 10 to base 2, use our tables, whatever. The maximum value that can be represented is 2 raised to the number of bits power minus 1. Okay, so for example, if I have 8 bits, what's the biggest number I can represent? 2 to the 8th power minus 1. Well, 2 to the 8th power is 256 minus 1. 255 is the biggest number I can represent in 1 byte. Okay, the reason it's minus 1 is because I have to represent 0. If you think about it, it gets you there pretty well. If we used a 1 byte unsigned integer, 255, the data type tinyInt is 1 byte. If we have a 4-byte unsigned integer, we would be able to go up to about 4 billion or so, 2 to the 32nd power minus 1. That's simple. It's just a straight conversion from base 10 to base 2. Do your mathematics in base 2, show it to you in base 10. Once we get a sign in there and we get positive and negative integers, life gets a little bit more complicated for us. And if we think of going 1 degree west, for example, as -1, and 1 degree east as +1, or flip them if you want to, notice that the greatest positive number is 1 integer away from the greatest negative number. Here's a trick question that I always ask. Works better in class face-to-face. What state is farthest east in the United States? Guesses?
Florida?
Okay, that's a good guess, but I mean, we're talking, it's a trick question. I'm telling you, it's a trick question, and look what we're talking about. If you go far enough west, you end up east in a circle. And as we're the farthest east you can go is also the farthest west you can go if you take one more step. So if you start walking west, you will eventually, well, given that you can walk on water, you will eventually come to zero longitude, excuse me, zero longitude. You take one more step and you've just stepped into the eastern hemisphere. Now you have east longitude. So the farthest east state is Alaska, because the Aleutian Islands actually extend into the eastern hemisphere. I told you it was a trick question. I guess they made it jog around. They jogged the international date line around the Aleutian Islands. I guess that's so you won't be able to throw a newspaper from yesterday into today or something. It doesn't quite work that way. But anyway, the idea being that as you get into the positive and negative numbers, the greatest integer, the largest integer you can get, is one number away from the most negative integer you can get. So if you take a very, very large positive number and you add 1 to it, you can end up having a negative number, a very large negative number. And that's quite possible. This is called overflow. And I do suggest you watch this video. Let me talk a little bit about, how much storage. This table right here tells us it's got a whole lot of numbers on it. Basically, it's got 8 bytes. I'm not too interested in these numbers. Remember that a type integer uses 4 bytes. That's something important to remember. Tiny int is 1 byte. As we move up, we double the number of bytes that we allocate, 1, 2, 4, 8, but we do a lot more than double the number of our range. So for every bit that we add, we double the range of it. So if we have 1 byte, if we have 8 bits, and I can go from 0 to 255, in other words, 256. If I go to 1 more bit and I have 9 bits instead of 8, now I can go from 0 to 511. So I would have 512 bytes. So a range of 512. As we move up, we double. Each time it doubles. Okay, here's what I wanted to get to. Overflow. You know, I know I'm getting old when all of my examples have fallen off of the scale. Years ago, when I was a kid, had to walk to school 2 miles through the snow. Automotive speedometers, or odometers, I should say, would overflow at 99,999 miles. So this is the old-timey ones that were mechanical. Today, we just have more digits than that. They still overflow. Now that they're digital devices, it's cheaper to add bits to the number. But what happens when you run out? Let me go to my little, okay. Here is a vehicle odometer from my 1968 Volkswagen bus, old hippie van. And it's got 999 miles on it, fairly new, 00. And if I drive 1 more mile, I now have 1,000 miles on it. Pretty straightforward. If I keep driving, I finally come to the point where I've got 9,999 miles. I drive 1 more mile, I have 10,000 miles on it. And I keep driving and driving and driving and driving, and finally I come to the point where I am full. 99,999 miles. What happens when I drive 1 more mile? And we say it resets to 0, or it rolls over to, now it shows 0. Is the number 0? No, the number isn't 0. What has happened is we have experienced an overflow. You get an overflow when the carry goes out of range. I don't have enough bits in my number to represent it now. By adding that one more number, I went out of range, and now I see it as 0. Oh, it reset. No, it didn't. It just carried out of range. So an overflow is an integer carry out of range to the left. Now, overflow is fairly easily detected. What does the computer do when you overflow? Different applications do different things. Some computers, some programs, for example, if you're talking about C or Java, well, C anyway, if you overflow, it just shows you 0. Okay. Others like Java, for example, will stop you and throw an exception, error. Others do some strange things. Some things just stop adding numbers to it, and boy, that I don't like. I either want it to do what I expect it to do, which is just to overflow and roll back to 0, or give me an error. But some things, if I tried to add 1 to this number, there are some programming platforms that will just not change that number. They just say that this number plus 1 is just this number, and so they just stop adding, which that's wrong. That's just immoral. But it carried out of range. So what is overflow? What did I say? There's a test question somewhere. Yes, there's a test question. Overflow is a carry to the left out of range, and overflow is an error on the high side. Overflow is usually a big error because the difference between 100,000 and 0 is quite large. What can I do about overflow? I just have to go get a bigger integer. Remember, if I'm using int and I'm overflowing, the only thing I can do is go up to a big int. What do I do if I overflow a big int? I got some pretty big numbers. There's ways to get around it that are beyond the scope of this class, but they are really, I have to string a whole bunch of them together, what it amounts to. All integers represented, here's an important point, all integers represented on any electromechanical device will eventually overflow, period. Take it to the bank, and your bank account will eventually overflow because it only has so many bits that it's represented in, although I doubt you'll ever get there. If it's unsigned, the value carries out of range to the left, and you see a 0. If it's signed, think of it as stepping from the Western Hemisphere into the Eastern Hemisphere, and that would be an overflow. So when I ask you what state is farthest east, I was essentially provoking an overflow there. If you go far enough west, you will overflow into the Eastern Hemisphere, so that would be an overflow. So the greatest positive number is one number away from the greatest negative number. So if you go bigger and bigger and bigger, and you finally add 1 to it, you will end up with a big negative number when it overflows. Nonetheless, it is fairly easily detected. All integers will overflow. Pause there for a minute. Questions? Second topic. Anything with a fixed decimal is an integer. If I fix the decimal, it is an integer in database. Not true necessarily in programming, but it should be really. Anything with a fixed decimal in database is going to get treated as an integer. Consider money. If something costs $17.23, I'm going to store it not as $17 and 23 hundredths dollars. I'm going to store it as 1,723 cents. That's an integer. The problem is that if I tried to convert the 23 hundredths to binary, I would end up with a non-terminating decimal point, but it would be a binary point because it's binary. And I would have to round it eventually. So I would have introduced a small, tiny little error into it. With that, so I would end up with a non-terminating point. But if I store it as 1,723 cents, it is an integer. Anytime we fix the point, it becomes an integer. So I have to fix that point. And that allows me to switch back and forth between bases without introducing a non-terminating decimal. If I have a number, I guess I could go into the factoring of it, but the numerator and denominator and the factors of them tell you whether something is going to terminate or not. And there's lots of things that you think will terminate. If I have a number like 0.04, 4 will, 0.03, or 30 cents, 30, 0.3, 0.30. $0.3. Does that terminate? Well, it does in base 10 just fine. It's 0.3. But if I tried to convert that to a base 2 and to get into binary, I would end up with a non-terminating string of numbers. Okay? So anything with a fixed integer. Now, most of our numbers in database are fixed. So we really don't like anything that isn't. Sometimes we're stuck with it. We have one type that is called decimal and another one called numeric. They are the same. You may use either one. I think decimal has been preferred, but Oracle likes to use numeric. So decimal, if I say something is decimal, then I'm saying it is a fixed decimal. Okay? If I say, let's see, example, decimal, let's give it this one, decimal, number, and so the second one is optional. If I say decimal 8, I say I want a number that is big enough to hold 8 base 10, a number containing 8 base 10 digits. Let's see, that would be what, 10 million. So a number that is big enough to hold at least 10 million, be 99,999,999. So a number that can hold 8 decimal digits. Now, you know as well as I do that they're stored in base 2. So it's going to have to allocate a little bit more memory than that. So likely they'll go a little bit bigger than that, but it's at least big enough to hold 8 decimal digits. Of these 8 decimal digits, of these 8, 3 of them are to the right of the decimal point. It doesn't make any difference at all to how much storage is required. It still has to hold 8 decimal digits. And it puts the decimal point 3 places from the right. That's fine. It just remembers that. And when you give it a decimal, it shifts the decimal. When you give it a number that's big, whatever it is, it's going to shift the decimal point 3 places to the right by multiplying, and it's going to store it as an integer. Then when it shows it to you or uses it, it's going to shift the decimal point 3 places back to the left and to get it back into the space that it was. So it stores it as an integer. If it stores it as an integer, it doesn't have to worry about rounding errors. We're going to get to rounding errors in just a moment, and they get thorny. The nice thing about integers, the error to which integers are vulnerable is overflow. If an integer gets too big, it overflows. Now, I can overflow decimal if I gave it too big of a number. Decimal, I want a decimal that'll take 2,000 digits. I don't think it'll give me that. So I can always get ridiculously big. But in general, and for working, the decimal type will go large enough. Remember, if you say it is decimal, it is going to be stored as an integer. Okay, and then here I say, how big is it? Well, it has 8 digits. That means it will contain up to 100,000 different numbers. And then I talk about taking a log base 2. I see that it will require 27 bits. We cannot allocate 28 bits, so we would go up to 32 bits. And to this number, we would allocate 4 bytes. And the way we got that is I ask, well, how big does it have to get? How many different numbers do I have to have? Well, if it's 8 decimal digits, it's that. I take a log base 2, put it into my calculator, and I see that it's bigger than 26, less than 27. So I round up and I say it's 27 bits. Add 1 more because it's got to have a sign on it. So that's 28 bits that this guy's going to require. Have to have 28 bits. And then I point out, I can't allocate 28 bits. That's, what, 3.5 bytes. I can't allocate 3.5 bytes. That's silly. So what I would do, I would allocate 4 bytes to that number. And 4 bytes is just real common. That's a pretty good sized number, but hey, it's not big by computer standards. So we can figure out how much memory something takes. Money is always 8 bytes. Always 8 bytes. Money always fixes the decimal place at 4 places. That's why if you don't say one way or the other, you will see money printed as having 4 decimal places on it. Yes, that's because money has 4 decimal places. And money has a fixed decimal place, therefore money is an integer. We won't have any rounding problems with money. I hate it when I lose a fraction of a penny. Anybody ever see the movie Office Space? Tracy, did you see Office Space?
I personally know, but I've heard so much about it.
Yeah, it's a little risque, but not bad. I think it's an R rated, but it's a soft R.
Oh no, I didn't mean it that way. It's just
well, yeah.
very silly.
It's silly, yes. They have a scam in the movie where they are collecting, and a very real scam, where they're collecting the very small fraction of a penny from every transaction. So they have a rounding error. And that's a very real scam, very, very real. I'll get to that one in just a minute, well, if we have time. All integers are limited by the number of bytes allocated, or actually I should have said the number of bits, but can't allocate a bit, so it have to be bytes. Bytes are typically 1, 2, 4, or 8. Once upon a time, SQL Server tried about 2005, 2004, somewhere in there. They tried to allocate 1 bit. So they tried to have a 1-bit integer. It could be 0 or 1. It was considered to be a dismal flop. It just didn't work because I don't really need it. If I want something that is either true or false, I allocate a tiny int. So I do not have a true or false value. I allocate tiny int, and if it's 0, it's false, and if it's not 0, it's true. It's typically the way I do that. And you do that in the logic of your program. You don't have many programming languages give you a Boolean data type. You don't have that in database. You just have to do it. You just make your own. But I have something that gives me 1 byte. When you look at the Boolean data types in Java or C++, you find that they take up a byte. I really can't allocate less than that. Summary, get that. Anytime we fix the decimal point, it is an integer. All integers overflow. What is overflow? Overflow is a carry to the left, important point, to the left, to the high side. Overflow is an error on the high side. It carries out of range to the high side of the number. And before you get out of here, that's going to be on a test. What is overflow? Overflow happens in every programming language that has ever been designed. Overflow happens in every representation of an integer that has ever been made. I don't care whether you're on an Abacus or a TI-99 calculator. It will overflow. Next. Floating point. Ew. Cringe at the thought. I think this would be a good point to stop because there's a big break here. There's a big logical difference between an integer and a floating point. There is a huge gulf between them. Integers are nice. Integers never have, integers have errors. They have overflow. But that's about the only error. When it overflows, it's obvious. The problem with floating point is that these little bitty, teensy, tiny little errors creep in. And they're very difficult to detect. Well, I don't really need to detect them. I know I'm going to get one every time every calculation, I get this little bitty tiny error. And where would that happen? Well, it would happen anytime I was working with degrees. In degrees, what do I have? Anytime I have a degree, I have that, remember that magic number, what do we call it? Pi? And what's pi? Pi is the ratio of the, well, never mind what it is. This isn't a trigonometry class, but pi is an irrational number. Pi never terminates, it never repeats. Therefore, anytime I have pi, or anytime I have a degree, if I have a degree, it's just pi divided by 180 is all a degree is. And so I have pi in there. So if I talk about, 30 degrees, I have that degree. I can't represent that degree accurate to the absolutely. Therefore, I'm going to get a tiny little fraction of an error. Oh, we're talking about the space shots now because it's what, the 50th anniversary of the Apollo 11 launch, I believe. I don't know. I was in Vietnam then, so I don't remember it. I don't know. Must have been having a good time. But the well, there was a early orbital launch where the poor guy didn't even land in the right ocean. And there wasn't anything wrong with the program, except they had one of these compounding errors in it that accumulated and accumulated and accumulated. And finally, after it was the first multi-orbital flight, and finally, after several orbits, this approximation for pi built up so many errors that he was way off of his target. I talk about here some common fractions, whether or not they terminate or repeat. 1/2 t, that means it terminates. 1/3 repeat. One third repeats, terminates, repeats. And I say, what is the rule? I don't know if that's real important. You can take a look at it and see. A computer represents numbers in base 2. The floating point decimal, 0.2, will not terminate in binary because that is 2 over 10, and 10 has a factor of 5. 5 is not a factor of 2. So the only things that can terminate are powers of 2. This is called underflow. And I'm not going to get too much into this number theory. I don't want to get way into that. Underflow happens because we cannot represent an infinite anything. Therefore, we have to end it someplace. When we end it, if you consider the fraction 1/3, what is the fraction 1/3 in decimal even? Well, it is 0.33333333333333333, and where will I finally run out of patience of sitting here saying 3, and I finally say, okay, that's it, that's close enough, and terminate it? I have introduced a tiny little error into that, and that is underflow. That is underflow. So I'm going to leave with this, and we're going to talk more about that. Overflow. Overflow is drastic error on the high side. Overflow is integers. Integers overflow. Floating point decimals do not overflow. Underflow is an insidious error that is so tiny it's not considered it's not considered important. Right. Overflow doesn't happen very often. When it does, it's in your face. It's obvious. Underflow happens on almost every floating point calculation and adds up. Bottom line is you never use a float unless there's no way around it. Never. Well, unless you have to. Sometimes you have to. If you're compounding interest, continually compounding interest, in other words, you got one of those E times P to the RT equations in there, then you're going to have a float, because some things are just irrational. A lot of the world is that way. Float takes 8 bytes. Do not use real. I'm gonna come back in here. It is now 7 o'clock, so I need to go try to figure out what's going on with my I think I'll go use my wife's computer and see if I can see it on there. So I need to go try to fix that July 9th lecture. I will get it fixed. It'll be fixed by today. I can see it okay. You just can't. I think the reason I can see it is because it's not set to public. Questions?
I would actually like to ask you some questions, but I don't want to take up time on the recording.
Oh, I can cancel the recording.
Because I am confused about how can you declare even money int and not anything, with prime numbers. You divide a prime number like 23 by anything other than itself or 1, you have the never-ending decimal point. And so I don't really understand how you can say that a variable is an int unless you're saying that int never. Do we say that ints never round up? They always round down. Is that why we have the remainder? Because you have a modulus.
Yeah, modulo is the way you get around that. For example, if you're going to divide integers, and I have an integer 7 divided by 3. 7 divided by 3. So 3 goes into 7 2 times. Integer 2, the quotient is 2. The remainder is 1. So 7 div 3, and we usually say div. That's kind of it's geek speak, as opposed to divided by. When you say div, you typically mean that you are taking just the quotient, throw away the remainder. The 7 div 3 is 2, integer 2. Then you have the modulo operator. We're going to talk about that in this section too, by the way. 7 modulo 2 is 1. Throw away the quotient. So you get the idea. It's 2 remainder 1. And since I know the divisor, I know that it's 1/2. 7 divided by 2, yeah. it's I just have to interpret it. So it's 2. No, it's 1/3. Excuse me. 2 remainder 1, and that is a perfect quotient. If I were to try to do that 7 divided by 3, 7 divided, I forget what I was saying. 7 divided by 3 is what I was trying to say. And I were to do that and try to carry it out as a decimal, I would get 2 point.
Right.
Anyway, I would just carry it out. 3.
But so the point being then is if you declare a variable as an int,
Yes.
that's how your division will work. If you declare that variable as a floating point decimal, it will give you the 2 point whatever.
Okay.
So it's 2.333.
It depends on how you write the operation. Now, if just because I made it an int doesn't mean that I can't divide it and treat it as a floating point. So we're going to cover it this time. I'm going to say I can just by magic, I can say, okay, poof, you are now a floating point 3. A minute ago, you were the integer 3, but now you're a floating point, and now I can make it happen in floating point, or I can go back and make it happen as an integer. So we're going to talk about that in this section. How can money be an int? You just declare it as money. You just say, give it a name and say it's money. And it automatically will have 4 decimal points. And since they're fixed, it's going to take care of all the rest of it. You don't have to worry about it.
On that 4th, decimal place, will it round up or down?
You can do what you want to with it. It will not round because it is an integer. So if you do division with it, you will get you'll get a month.
The whole.
You'll get a
Right.
quotient and a remainder, and you do with it what you want to do with it. If you want it rounded up, you say, show it to me in pennies rounded up, it will show it to you in pennies rounded up. If you say, show it to me truncated, it will truncate it for you, but it will always store it as an integer. And then it will put the decimal point 4 places to the left of the 4 places into the number.
Okay.
If you just put if you say money and you store the number 27 in there, it will be stored as 27, pretend decimal point, 0000, and it will be stored then as 270,000. But when it shows it to you, it'll put the decimal point back in.
Okay.
Yeah, it's a little strange, but you don't have to worry about it in terms of money. It's just the floating point. The whole point, the thing we're going to talk about here is that floating point, you have to be real careful with it. And you don't want to use float if there's any way around it. The only time you'll have to use float is if you're calculating interest compounded continuously or degrees.
And is that just because of the memory allocation?
You mean interest?
That float's going to take up, if you float and you allow it, you have to truncate it at some point, otherwise you're having to allocate too many bytes of memory.
Well,
so that's what I'm saying. You avoid float simply because of of conserving memory?
No, I avoid float because I don't want to truncate it, because when I truncate it, I've introduced that tiny little error, and I'm going to have to do that almost every calculation. So I've got this little error that can accumulate over a period of time.
But okay, so with 7 divided by 2, and I say, okay, I want the outcome of that. Okay. It stores it not only as an int with the 2, but it stores the modulus separately?
No, it stores it however you say to store it. So if you just say 7 divided by 2, it would, and if they were both integers, you would have to say divide. If you just say 7 and put divide 2, you're going to get it. You're just going to get the quotient. Is going to throw away the remainder. If you say mod, you get the remainder.
Right.
So you
I'm having trouble understanding how integer doesn't truncate, how it saves that, and I understand the way to save that is to store that modulus, but does it allocate memory for the integer plus, or you know what I mean? How do you keep track of that modulus? How do you not lose it somewhere?
Well, that's called, you have to do it in your program. You have to program for that. So your program will say, how do you want to do this division? We're just doing the queries right now. So if you say, I want this number to be, I want to select 7 divided by 3. It will probably show it to you as a floating point. I just have to try it and see. Try it as a query, say select 7/3 and see what it gives you. I think it'll give you a decimal point. It'll
I don't think it did, actually.
Oh, try it. Let me just try it here. Select 7 divided by 3. Let's see what we get. Execute 2.
Right. Because that's the whole point. If you don't, it says division is always integers and modulus, is how you get that remainder.
I believe it's mod. So
percent sign will do it.
Well, percent sign works also. Okay.
Yep. 7% sign 3.
That's real common. So it takes both of them. You have to have both. And so 7 divided by 3 is 2, 7 mod 3 is 1. So the answer to this question, what is 7 divided by 3, is 2, remainder 1. That is a perfect answer. If I said select, I can say something different. I can say select 7.0 divided by 3, and I think now I'm going to get a decimal, and notice I got a whole bunch of 3s there, and it just chopped it off. Now I have an error there because this answer is not perfect, because why isn't it 2 3? I've got 6 3s. Well, why wouldn't it be 7 or 8 or 10 or 10,000? I'll never get to the exact answer. But this one, these two together give me an exact answer. And how does it keep it straight? Because that's what I ask for.
So is that how it's done in database, that you have to always keep a column for
Yes.
Okay. So that's how you keep
That's
track
how it's
of it.
done in programming.
Okay.
It's not just database, that is programming. And it is just an issue, but the beauty of the integer is that you have 2 different ways to divide. Both of those are division operations, both the slash and the modulo. The modulo gives you the remainder, and the slash gives you the quotient.
Right.
I'm going to end the recording now.
Thank you.